Alrighty, we are in Unit 1, Module 4, Session 1. Your home connection is measuring lengths. We're going to start on page 1. Why? Because that's a great place to start. Or you could start by putting your name at the top with your number. The number helps for our mailboxes. It helps it easy. It makes it easier for us to sort them. Alright, question is, would you use centimeters or meters to measure the length of these items? Now, if you remember, our centimeter is quite small, right? Here's an example of a centimeter. Hopefully you can see that in the reflection. So from here to here is a centimeter. Here's my pen. It is quite a few centimeters. If you want to be precise, when it's open, it's about 15 centimeters, right? So they're pretty small. Now, if you're going to measure your bedroom, would you want to measure your bedroom in bits that are this small? Or would you like to use meters, which would be about three of these rulers? It's going to probably be easier to measure using meters. Because man, I mean, your bedroom might be, what, 30 feet, which is about, what, 10 meters? So you could use maybe 10 meters to measure. Or you could have to measure that in 10,000 centimeters, right? My brain's a little slow today. Sorry it's taking me so long. How about your big toe? Toe's not very big, so probably going to measure that in centimeters. By the way, if you've already done this portion, you feel very comfortable, you can always skip ahead in the video. A car, that's quite a bit bigger than one of these, so we should probably use meters. A mouse, wow, a mouse is way smaller than a car. Maybe a little bit bigger than a toe, but we can still measure that in centimeters. And then the gym, oh my goodness, your PE teacher, it would take them all day to measure it in centimeters. These little tiny measurements here, so we probably better measure that in meters, okay? Question 2, we're going to fill in the table below. What kind of a table is this? Well, to me it kind of looks like a ratio table, because we have a number that relates to this side, and as you move down, the correlation continues. So, fill in the table below to convert between centimeters, that would be cm, and meters, m. The first two rays are done for you. Thank you, worksheet. You are so kind. Okay, and I'm just now noticing that this looks pretty small, so let's zoom in a little bit, give you a little bit more to look at. Okay, 1 meter is 100 centimeters. That's what we learned in session 1, okay? So that means if we double that to 2 meters, we should double the 100, right? For every 1 we go up, we go 100 up on this side. Now, so I went from 1 to 100, 2 to 200, something to 300. Well, what's our pattern? We're adding 100 on this side, so we're adding 1 on this side. 2 plus 1 is 3 meters. You can always pause this if you want to try this on your own before you follow along with me. Now, 3 to 8. Oh my goodness, how many am I adding here? 5. So if I'm adding 5 on this side, I need to be adding 5 100s, right? So 5 100s would be 500. So I'm going to add 500 to that 300, and I should get 800 centimeters. Okay? Now, ooh, goodness! So I went from 800 to 2,500. 2,500 centimeters. Well, I'm noticing a pattern. This is just this number with 2 zeros, right? So if I think that 1 is 100, 2 is 200, 3 is 300, 8 is 800, how many meters is 2,500 centimeters? I just need to get rid of 2 zeros, and I have 25 meters. Do you see how I did that? You just add 2 zeros. 8 plus 2 zeros is 800. 25 plus 2 zeros is 2,500, or 2,500. So what would I do over here? What would be the opposite if I'm at 31 meters? You can pause this if you want to think. But the answer is going to be add 2 zeros. 3,100 centimeters. Okay? The nice part about meters to centimeters is that 100, because you are just adding 2 zeros to get the number. We could do it a little bit harder. We could count 131 times, but we just did by adding 2 zeros, 3,100. Okay? Question number 3. For each of the following story problems, show your work. You can number it, you can label it, you can sketch it, you can just simply write words. We need an equation, including the answer labeled with the correct units. Okay? Chloe is a baby who is 24 inches tall. So I'm just going to write a human, and I'm going to do a little measuring stick here that says 24 inches, because those are our units, right? Her father is 3 times as tall as she is. So who's taller, the father or the baby? The father. How many times? 3 times taller. So that would be like taking 3 Chloes and stacking them on top of each other, right? That would be the same height as the dad. Okay? So I would have a 24, a 24, and a 24. You could add them together, right? We could do that. So if I wanted to stack it that way, I could think of it this way. I could say 24 plus 24, so that's 48. And then I add another 24 to that. That's 12. Carry the 1, 4, 5, 6, 72 inches. That's the answer. If you wanted to do it using the stacked math algorithm, the multiplication algorithm, we could take 24 times 3. We're going to get the same answer. 4 times 3 is what? 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. You still get the same answer. Make sure you label it 72 inches, please. Okay, let's do this thing. Question B. Chloe's dog, oh, so cute, Wilson, is 27 inches long. So here is my here is my stick dog. Little nose. So this dog is 27 inches long. So from there to there, 27 inches. Chloe's hammock, you know, that little swingy thing that people kind of lay in. Sometimes they're attached to trees. Sometimes you have a stand in your yard that you put them on. But Chloe's hammock is 4 times as long as Wilson. So I could put 4 dogs in there, and it would be the same as the hammock. So that would be 27 4 times. You can stack and add if you'd like, or we could try the algorithm. I highly recommend it. It's a great skill to know. Stack it with the smaller number on bottom. We're going to start by multiplying the first digits, 4 and 7. 7, 14, 21, 28. What do I do with the 2? Oh yeah, I carry it. Okay. Now I'm going to apply the 4 to the 2. 4 times 2 is 8, plus 2 is 10. 108. What's my unit? Inches. Now here's where it gets a little challenging. By the way, have I mentioned you can pause this video whenever you want? Yes, you can. My favorite part is that you can re-watch it if you want to. YouTube will even allow you to slow the video down if you think I am talking too fast. And I apologize if I am. Okay? You can always re-watch, okay? A small table. Oh my goodness. A small table. Here's the legs, okay? A small table is 2 feet by 3 feet, okay? A large table, oh my goodness, my math or my drawing skills are not amazing. By the way, these are the table legs here, okay? A larger table, twice as long, twice as wide, okay? So twice as long, so it's 3 long, or we'll say, I don't like the way I drew this, but this will work. So we'll say if this is length, okay, then it must be twice that. What would be twice of 3? 6. And it's twice as wide. 4. 2 times 2 is 4. What is the area of the large table in square feet. They told us the units. Okay? What is area? That would be like if we made a tile array, right? Like how many tiles fill in the entire thing, right? That would be our area, okay? How much of this we can cover. And we know that to do that, we have to multiply the dimensions, the length and the width, to get the area. So I'm going to take 4 times 6. So we can write our equation, maybe over here. 6 times 4 is, or you could write 4 times 6. You get the same answer. Count it with me by 6s. 6, 12, 18, 24. So my answer is 24. Okay? I missed one thing though. What am I missing? My units! Oh my goodness. We need to say square feet. And as you get older, you'll learn that we can make that a lot simpler by doing maybe like ft squared, but don't worry about that for now. Square feet work for now. Not circular feet, not rectangular feet, square feet when we're talking about area, okay? Hope this video was helpful. You can always find your teacher and ask questions if you need.